we think of accuracy as how close something is to the actual value, right? How close to the actual value. Maybe we take a measurement, or maybe we try to make something. Now, precision, precision is about how repeatable a measurement is. Now, in everyday usage, these two words are often used interchangeably, but in physics, accuracy is normally related to systematic error and precision to random error. So let's take an example. Let's say we have someone, a boy, right? Let's say he's throwing a dart. Now, so there's a dart, okay, a little darts that he throws. It's not a very nice dart. Okay, let's say just something like that, right? That flies. So he throws this dart, and this dart flies through the air, and he aims it at a target. Right, let me draw a target. So there is this target here, the big circle, all right, and at the center is the bullseye. Okay, that's the bullseye, and well, as always, there might be rings around it to show the target. So his dart lands on the bullseye. Now let's take a look at where his dart lands. Okay, suppose that his dart lands somewhere around here, there, and there. Okay. So now, let's say his darts land somewhere around here. Let's think about how accurate and how precise his aim is. Okay, in order to illustrate my points, what I'm going to do is this. Suppose that his darts always lands very close together. Right. Let me say that his dart always lands around this point. All right, always lands very close to a small area. So what we would say then is that his aim is very precise. Okay, so let me say that his aim is very precise because it's very repeatable. He always hits the same spots very, very closely. But we say that he's not very accurate because although he always hits the same spot exactly or very closely, he's always far from the actual bullseye itself. So we can say, in this case, we might say that he's very precise, but he's not very accurate. Now, but what does this mean in terms of the types of error? Well, you can see from the previous video on systematic and random error that what this means is that if this bullseye is where he wants to be, then all his aims landed on a spot which is always at the same distance from the bullseye. So he has a systematic error, all right? He's always at a fixed distance from the bullseye. So the difference is the systematic error. Okay, so this systematic error tells us how accurate he is. The bigger the systematic error, the less accurate he is, because the less close or the further away from the actual value. Okay, so I can so this distance, therefore, this distance here is the systematic, is the accuracy, and it corresponds to the system. Right? I should write this out. I should call this the systematic error. And now the precision, where are we? So the precision would correspond to the random error. Now, the random error happens because in reality, we would expect that he would not really hit exactly the same spot down here. Right? He would not always hit exactly the same spot. So we would expect that around this area there is some random error. Write this out. There is some random error. So that's, although it's very close to this spot, each of its aim could be slightly different. Right? That's the random error. Now there is, if we like to represent this idea graphically, this is how we can do it. We can imagine plotting a graph. Now that's x. Okay, that might be say, we might call it f for frequency. That means how many times the dot lands at a certain value of x, and x might be, say, the distance from the bullseye. Now if we imagine each time he lands on a spot, okay, we imagine plotting the distance as a dot here. Okay, if he throws another dart, plot another distance of x, we plot another dot there, another dot there. But each time he lands on the same or close to the same x, we might put a dot a bit higher up. Now we might end up with a graph that looks like this, some kind of plot that looks like this, where all his aims are centered around some very closely around a certain distance from the bullseye, and the bullseye is there. So that's the bullseye. All right. So, and because all his aims land very close together, we say that it's very precise, because it is very repeatable. They're all very close to the same spots. But because all these aims are quite far from the bullseye where he really wants to be, okay, so this distance becomes the systematic error. Okay, so let me draw systematic error. So this value here would therefore correspond to the systematic error, and this width, the width of this spread if you like. Let me represent this by two arrows here. Roughly the distance from one side to the other, how wide this group of points are. So this would roughly tell us the random error. So this distance tells us the random error. So that's accuracy and precision.